Welcome back with another video on TryHackMe.com. This is Zaheen Azeen, and today we are doing multi-factor authentication. So before we continue with the room, if you haven't subscribed, please subscribe to the channel. Click on the bell icon to get the notification once a new video is up on this channel. This is out of the way. Let's continue with the room. So multi-factor authentication, exploiting multi-factor authentication. It is easy and it will take 60 minutes. I already started my attack box here, and I already started the attach VM as well. So we have total task 1, task 8. Let's continue, guys. Okay, multi-factor authentication MFA plays an important role in the modern day applications. Instead of just relying on a password, MFA throws in extra layer of defense. So I highlighted that the multi-factor authentication should be applied once you implemented the OAuth 2.1 and above, right? So this was missing, and fortunately the new room with the same title is available on TryHackMe. So we are fortunate to have this available to us, and let's get into it. MFA is a okay, so if you need to get to the definition, so MFA stands for multi-factor authentication. Is a security process that requires user to provide 2 or more form of authentication before accessing an account or system. This enhances the security by adding an additional layer of protection against unauthorized access. Awesome. MFA is a combination of different checks. It might be something you know, like a password, something you have, like a smartphone, something you are, like a fingerprint, or maybe eye scan or retina scan. By using these layers, MFA makes it much tougher for threat actor to access user accounts or applications. Objectives. By the end of this room, you will understand the operational principle of MFA and its significance in strengthening an application's security posture, explore the different types of authentication factors used in the MFA setups, get insight into the practical scenarios where MFA is implemented to protect sensitive data and systems. Okay, awesome. Prerequisite. Before starting this room, you should have a basic understanding of the following concept: familiarity with general concept of authentication mechanism, including knowledge of how passwords and simple authentication processes work, basic proficiency in navigating and using Linux command line, and completion of the enumeration and brute force room. I think I already have enumeration and brute force room done. Just check the video over there. I will put a reference to that video. Starting the machine. Okay, I already deployed the machine. Target machine. Attach this task by pressing the green start machine button after obtaining the machine's generated IP address. You can either use the attack box or your own VM connected to TryHackMe VPN. So I'm going to use the attack box. Add 10. Okay, so this is what we need to add. So let's do that. Okay, so there is a very simple way that you can use. Either you can go with the nano and just go with the host file and directly paste the configuration here. I think let me remove the extra spaces here. All right, just one space. We are good to go. Control O to save, press enter, Control X to exit. Just cat it again to see the changes are there. Yeah, changes are there. Now let's see if this is also accessible on the browser side. At least we'll get some error or something to make sure this is accessible, or we can just ping it. Okay, if ping is enabled. Okay, it is available, so we are good to go. Awesome. So the first task is completed. Let's move on to the second one. All right, how MFA works. In today's digital age, keeping your sensitive data and systems secure is more important than ever. Multi-factor authentication MFA adds extra protection to user account by requiring you to provide 2 or more verification factors. This makes accessing user accounts significantly more challenging for threat actors. This is very true. It is important to note that two-factor authentication is a subset of multi-factor authentication. Okay, two-factor is where you usually receive an OTP to an email address or mobile number. Multi-factor is more of a comprehensive or the superset of two-factor authentication. Okay, MFA refers to an authentication posture that requires two or more factors to be verified. Verify a user's identity. Types of authentication factors. Okay, multi-factor typically combines two or more different kind of credentials from categories: something you know, something you have, something you are, something you, somewhere you are, or something you do. Okay, so we will explain everything here. So we have the MFA umbrella here. Something you have, it could be a credit card or something like that. Something you know, maybe the password. Something you are, your identification, for example, fingerprint or retina scan or something like that. Something you know, this could be a password, a PIN, or other piece of information you have to remember. It forms the basis of most authentication systems, but can be vulnerable if not used simultaneously with other factors. Yes. For example, if there is just a password, there is no captcha on your website, somebody can do the brute force attack to get crack your password. So in order to secure your system, you need to enable either two-factor or multi-factor. So multi-factor is the way to go. Okay, something you have, this could be your phone with an authenticated authentication app, a security token, or even a smart card. Lately, we are seeing more use of client certificates, which are like digital ID cards for devices. So client certificates, like you generate your own certificate and then pass it to the system that you want to authenticate. So because this certificate is available in your system only, nobody else can basically steal it, and the communication between you and the server will always be encrypted. Okay, or if not encrypted, then the login process will require you to have a certificate in order to continue. Okay, all right, something you are, this involves biometrics such as fingerprints, facial recognition, or iris scan, retina scan. This form of authentication is gaining popularity because it's tough to fake and it's now found in many of our gadgets, from smartphones to laptops. It's important to note that a fingerprint never matches 100% and a face scan never matches 100%. So this is the one factor that should always be supplemental and never used in a pure isolation. So it's like whenever you scan for your fingerprint, there is no 100% match. It is always like close to 90, or I don't know what is the actual ratio that different systems are using. Because if you go for the 100%, then in this case, the processing power and the time required to make sure that the fingerprint is matching 100% is much more than what normal user should wait. For example, if you are using the fingerprints on your mobile, then it is not 100% match. They will match few areas of your fingerprint, and if it is there, then okay, and they will unlock the phone. Same is true for the face scan and other things. Somewhere you are, this involves your origin IP address or geolocation. Some applications like online banking services restrict certain activity if they detect that you are making a request from an unknown IP address. Basically, this can be masked if you are using a VPN, so they will not know your actual location from where you are accessing the service. Okay, something you do. This kind of authentication is usually used in applications that restrict bot interaction, like registration pages. The application typically analyzes the way the user types the credentials or moves their mouse, and this is also the most difficult to implement since the application requires a specific amount of processing power. Okay, I think this kind of authentication is already there if you are using your company's account with Microsoft Windows latest version. So for example, if you type your password very quickly, then it will say that okay, Please type the password again because you are doing it very quickly, but they will not tell you that you are doing very quickly, but they will say password is not correct. Okay. Two-factor specifically requires exactly two of these factors. So while all two-factor is MFA, not all MFA is two-factor. For example, an authentication system that requires a password and fingerprint scan and a smart card would be considered multi-factor, but not two-factor authentication. Okay, kind of two-factor authentications. Okay. Let's check this out. Two-factor can utilize various mechanisms to ensure each authentication factor provides a robust security layer. Some of the most common methods include time-based one-time password, TOTP. These are temporary passwords that change every 30 seconds or so. Apps like Google Authenticator, Microsoft Authenticator, and Auth use them, making them tough for hackers to intercept or reuse. Okay. I think there was a news that they were able to bypass the Google Authenticator using AI. I'm not sure if it's still there or not. Push notification. Application like Duo or Google Palm send a login request straight to your phone. You can approve or deny access directly from your device, adding a layer of security that verifies possession of a device registered with the account. An attacker involving push notification, the MFA fatigue attack enabled an attacker to compromise the corporate account of an Uber employee. Details of this attack are out of the scope for this room, but to learn more about what happened, you may visit the Uber's official security newsroom, which can be found here. It is interesting. I will visit after completion of this video. SMS. Most of the applications currently use this method. The system sends a text message with one-time code to the user's registered phone number. The user must enter this code to proceed with the login. While convenient, SMS-based authentication is less secure due to the vulnerability associated with intercepting text messages. Okay. Hardware token devices like YubiKeys generate a one-time password or use NFS for authentication. They are great because they don't need a network or battery, so they work even offline. Awesome. Conditional access. So conditional access nowadays on the cloud computing side, for example, on the Azure side, they are enabling the role-based access and also conditional access. So if you have permission, you still need to verified by the conditional access to enable your access on the resources that you're looking for. Okay, this could be either a primary kind of authentication or it could be used in conjunction with the other authentication that we have here. Okay, in conjunction mean in a multi-factor authentication way. Conditional access is typically used by companies to adjust the authentication requirement based on the different contexts. It's like a decision tree that triggers extra security checks depending on certain condition. For example, location based. If a user logs in from their usual location, like their office, they might only need to provide their regular login credentials, but if they are logging in from a new or unfamiliar location, the system could ask for an additional OTP or even biometric verification. So the location-based authentication works, conditional access works based upon the scenario where the travel distance is impossible. So for example, before 5 minutes you are in US and after 5 minutes you are accessing from an IP address which is located in UK. So this is impossible distance that you can travel in this duration. So in this case, this location-based conditional access will trigger and will block your access. Okay, time-based. If during regular working hours, user might get in with just their regular login credentials. However, if someone tries to access the system after working hours, they might be prompted for an extra layer of security like an OTP or security token or security code. Behavioral analysis. Suppose the user's behavior suddenly changes, like they begin accessing data they don't usually view or access at odd hours. In that case, the system can ask for additional authentication to confirm it's really them. Device specific. In some cases, companies don't allow employees to use their own devices, like bring your own device. They don't allow it because of the policies and security. To access the corporate resources in these scenarios, the system might block the user after the initial login step if they are on an unapproved device. Global adoption and regulatory push. The adoption of MFA is rapidly expanding across various sectors due to its effectiveness in protecting against many common security threats. In fact, I think by October, Microsoft is pushing you to use multi-factor authentication, and they are deprecating a lot of authentication technologies that they were using previously, okay, to prevent attackers to compromise your account and use your account as a botnet, including phishing, social engineering, and password-based attacks. Governments and industries worldwide are recognizing the importance of MFA and are starting to mandate its use through various regulatory frameworks. For example, finance and healthcare sector are now implementing stringent MFA requirements to comply with the regulations such as GDPR in Europe. So GDPR is not health sector; it's just the regulation related to the processing of the data and personal information, which is available inside the Europe side, and HIPAA is health related, Health Information Portability and Accountability Act, the primary law in the United States that governs the privacy of healthcare information in the United States, and PCI DSS if you have worked with the finance before. So this is the standard you need to comply with if you are storing user payment specific information, for example credit card information or anything like that, okay, for payment systems globally. Numerous breaches such as the 2017 Equifax breach or the 2013 Target breach could have been prevented if the MFA had been in place. Okay, when logging into the system, you receive an SMS on your phone containing the OTP. What authentication factor is this? Something you have. Okay, something you have. I think so. This should be it. Yay! Okay. Going to task 3. Alright, multi-factor authentication MFA is now an important factor for keeping our online and offline activities safe from threat actors. From banking and healthcare to corporate IT, these industries rely heavily on MFA to secure data from attackers. This is very true. We have MFA in banking, MFA in healthcare, MFA in corporate IT. So I think most of you already experience MFA in any of these industries. MFA in banking. Banks handle incredibly sensitive information transaction every single day. By using MFA, banks can protect users' personal and financial information from cyber theft, fraud, and other online threats. Typically, banks ask you to enter a password, something you know, before moving on to the second layer of security, which is a code sent via SMS or generated by an app on your phone, something you have. This way, even if someone gets hold of your password, they still need that extra bit of information to access your account or complete a transaction. MFA in healthcare. In healthcare, due to regulations like HIPAA in the US, MFA makes sure that patient records and personal health information are only accessible by authorized persons. For example, to access sensitive information like electronic health records (EHRs), healthcare provider might require a doctor to use a security badge, something they have, and a fingerprint scan, something they are. This ensures that only those with the right credential can view or alter patient data. MFA in corporate IT. With the increasing number of cyber attacks and data breaches, IT departments in the corporate world are under intense pressure to protect sensitive business data and maintain system integrity. MFA helps mitigate the risk of unauthorized access that could lead to data theft, espionage, or sabotage. In a corporate setting, MFA is typically used when accessing company networks, databases, and cloud services. Employees might first log in with their corporate credentials, something they know, and then verify their identity with the code sent to their company issued phone, something they have, or through biometric verification, something they are. This way, even if someone tries to attack their system, they will hit a roadblock without the second factor. This is very true. Is MFA an important factor in keeping our online and offline activity safe from a threat actor? Yeah, I will say yeah. Okay, awesome. Let's move on to task 4. Common vulnerabilities in MFA. Weak OTP generation algorithm. We have application leaking the two-factor tokens, brute forcing the OTP, lack of rate limiting, usage of evil grin. This is a very good one. Basically, you can create your own infrastructure. So we will see how this works. Let's continue with weak OTP generation algorithms. The security of one-time password OTP is only as strong as the algorithm used to create it. If the algorithm is weak or too predictable, it can make the attacker's job easier. Trying to guess the OTP. If an algorithm does not use truly random seeds, the OTPs generated might follow a pattern, making them more susceptible to prediction. Okay. You can check this one if the OTP generation algorithm is generating the random OTP by using burp suit analyzer, which will basically tell you that if the OTP or the strings or the hashes that you are generating are truly random. Okay, and it will give you a lot of other stats and metrics as well, which will help you make the decision easier. Application leaking the two-factor tokens. If an application handles data poorly or has vulnerabilities like insecure API endpoints, it might accidentally leak the two-factor token in the application HTTP response. Due to insecure coding, some application might also leak the two-factor token in the response. A common scenario is when a user after login arrives on the two-factor page, the application will trigger an XHR. This is XML-based request. What do you say? The AJAX request to an endpoint that issues the OTP. Sometimes this XHR request returns the OTP back to the user inside the HTTP response. So what happens is, for example, the OTP should be checked on the server side, okay, not on the client side. So once user will enter an OTP, if you're checking it on the client side, that means the client should have original OTP available in the browser side. Okay, this kind of practice is insecure completely because you are exposing your two-factor token in the client side, and somebody with the knowledge or the tools will be able to figure this out, and your application will not be secured. So always use OTP verification on the server side. Brute forcing the OTP. This is the next big thing. Even though OTPs are designed for one-time use, they are not immune to brute force attacks. This is very true. If an attacker can make unlimited guesses, they might eventually get the correct OTP, especially if the OTP isn't well protected by additional security measures. It's like trying to crack a safe by turning the dial repeatedly until it clicks open. Given enough time and no restriction, it might just work. So with the computer processing power, and if you have the botnet, you can use a distributed operating system to brute force an OTP. So OTP strength itself is also of the consideration. For example, if it is just a number, then it is very easy to brute force. And if there is a rate limiting, or if you are using any kind of captcha to make sure that the traffic are not generated by any kind of bot net, and user cannot, for example, go beyond 3 tries, and if they are trying to brute force, after 3 tries the account should log for a specific amount of time. So these are all standard kind of practices to avoid or prevent or mitigate the brute force attack on the OTP side. Okay, so the next big thing is lack of rate limiting. Basically, if you have rate limiting, you will prevent the brute force attack and also denial of DDoS or denial of service attack or distributed denial of service attack. Without proper rate limiting, an application is open to attackers to keep trying different OTPs without difficulty. If an attacker can submit multiple guesses in a short amount of time, it increases the likelihood that the attacker will be able to get the correct OTP. For example, in this HackerOne report, I will see that later on, the tester was able to report a valid bug since the application does not employ rate limiting in the checking of two-factor code. Okay. The usage of Evil Jinx. So Evil Jinx is a tool that is typically apologies. Okay, I'm back. Evil Jinx is a tool that is typically used in a red team engagement as it can be used to execute sophisticated phishing attacks, effectively bypassing multi-factor authentication. It operates as a man-in-the-middle proxy that can intercept and redirect OTP meant for legitimate users. So let's see. So we have the Evil Green here. So a phishing attack will work like, okay, we'll send a phishing link in an email to a user. Okay, user will say, okay, this is the google.myfake.com, which will go to the Evil Jinx. EC2 means it is deployed on AWS EC2 instance. So what will happen is now the Evil Jinx will call the actual google.yml and get the legitimate response from the Google and send it back to the user from 4 to 5. And you'll say, okay, this is the actual response that I'm looking for. So in that case, what will happen after 5, the legitimate service is also sending the two-factor authentication to user mobile. Okay, the user receives the message saying that, okay, I'm accessing the legitimate Google service, so that's why I received the OTP on my mobile, right? Okay, then the OTP he will enter inside the website, which is google.myfake.com, which is hosted on the Evil Jinx 2 EC2. And then what will happen? Now Evil Jinx will generate a session cookie for the user, and the next thing is user can go and access the actual service that he is looking for. But in the same time, we have his session cookie, and also we are authenticated using two-factor authentication. That means we have the session of this user in our server as well. So both of us can use this session at the same time. All right. How Evil Jinx works is that when an attacker sends a phishing link to you, you enter your credentials on what looks like a legitimate login page. Evil Jinx captures your username, password, and OTP before forwarding them to the real site, giving attacker access using your cookies without needing to crack your MFA. Okay, what can be implemented to help prevent brute force forcing OTP? Rate limiting or captchas. Okay, awesome. Let's move on to the task 5. This is a practical that we need to do. Awesome. We are 26 minutes into the video, so I think we'll be able to complete the room before time. Task 5, practical OTP leakage. OTP leakage. The OTP leakage in the XHR XML HTTP request. Response typically happens due to poor implementation of two-factor authentication mechanism or insecure coding, as I explained before. Some common reasons why this happens are because of server-side validation and return of sensitive data, lack of proper security practices, and debugging information left in the production. This is very true. Server-side validation and return of sensitive data. In some poorly designed application, the server validates the OTP rather than just confirming its success or failure. It returns the OTP itself in the response, which is bad practice. This is often done unintentionally as part of the debugging, logging, or poor response handling practices. This is true, very true. If you have the development background and you know about this issue firsthand. Lack of the proper security practices. Developers might overlook the security implications of exposing sensitive information like OTP in the API responses. This often happens when developers are focused on making the application functional without considering how attackers could exploit these responses. Not all developers are fully aware of the secure coding practices. They might implement features like two-factor without fully understanding the potential risk of exposing sensitive information. In the XHR response, debugging information left in production. Oh, this is a big one. During the development or testing phase, a developer might include detailed debugging information in the responses to help diagnose issues. If these debugging responses are not removed before deploying to production, sensitive information like OTP could be exposed. This is very true. So exploitation, go to this website. Let's do that. I will open up a new tab, paste and go. We are here. Awesome. Log in the application using the credentials below. So this is the email. I will just copy it and test1-8 as the password. Test1-8. Okay. Note: open the browser's developer tool using bypassing F12 and navigate to the network tab first before clicking the login button. This tab allows you to see all the network requests made by the application, including XHR requests. So, we are late here. So, what I'm gonna do is, let's open the developers tool by going to the more tools and web developer tools here. Since we missed our window, so we don't have the network. So what I'm gonna do is, I'm gonna do the refresh here. So once I did the refresh, I can see there is call to a token here. And what is the response, by the way? Okay. So the response is this one, 5248. Let me paste. Verify account. And we are inside. Awesome, man. That was very simple. Very, very simple. Okay. Once you are in the MFA page, you will see an XHR request triggered by the application that is sent to the token endpoint. We already went through all of this and we were able to get the token. And I put the token into the verification, and here is the flag that we need to enter. Awesome, awesome, awesome. Good, good, good. Practical. Another one, insecure coding. Awesome. Logic flaws or insecure coding. In some applications, flawed logic or insecure coding practices can lead to a situation where critical parts of the application, i.e. the dashboard, can be accessed without fully completing the authentication process. Specifically, an attacker might be able to bypass the two-factor mechanism entirely and gain access to the dashboard or other sensitive areas without entering the OTP. This is often due to improper session management, poor access control checks, or incorrectly implemented logic that fails to ensure the two-factor requirement. Exploitation. Okay, so let's go to the exploitation. The email is the same and the password is also the same. I will open up a new tab here. Let me copy the email and test1-8. I'm logged in. Okay. Typically, the attacker first need to understand how the application logic and two-factor process work. In this case, after entering the username and password, the user is prompted to enter an OTP to gain access to the dashboard. Okay. Instead of entering the OTP, the attacker might try to manipulate the URL or bypass the OTP step altogether. For example, the attacker might try to directly access the dashboard URL, which is this one. Let's do that. Let's do that. All right, we have the flag here as well. So we bypass the OTP step itself. So in order to protect this page, what we needed to do, we needed to make sure that, okay, user is not logged in, and because this multi-factor authentication is required. So we'll send the user back to the login page or two-factor authentication page in this case. Okay. Diving deeper into the code, the below code is part of the code that is used in the MFA page. As you can see, the session authenticated is issued after the completion of two-factor process. The code is equal to session code function call in the MFA page. Okay. Considering the above implementation is secure, some instances of dangling issuance of the session authentication after the first step of the authentication will bypass the above code as shown below. So for example, we have authentication. Once user is doing the username and password, we are verifying that, and then we are creating the session is equal to true. So session authentication is equal to true should only be when user pass the OTP page. Okay. If you put it after username and password, that means there is a logic issue that we already compromise. So I'm gonna paste the dashboard here and we are good to go. Since the application dashboard only checks for value of session authentication, whether it's true or false, the attacker can easily bypass the two-factor page, considering the attacker has prior knowledge of the application endpoint. To remediate this vulnerability, the cookie or session that is used in the application authentication checks should be split into two parts. The first part is the one that sets the session after successful username and password verification. Sole purpose of this session is to submit a two-factor token. The second session should only be after the OTP is validated. Okay. Did we cover the similar kind of thing here? How to prevent it? To remediate this, application should not return the generated two-factor authentication or OTP in the responses. Instead of returning the OTP, it is required to return a generic message like success. This is very true. Okay, we are moving on to the task 7. Practical beating the auto-logout feature. In some applications, failing the two-factor challenge can cause the application to revert the user back to the first part of the authentication process. The initial log in with the username and password. This behavior typically occurs due to the security mechanisms designed to prevent brute force attacks on the two-factor parts of the application. The application may force the user to re-authenticate to ensure that the person attempting to log in is indeed the legitimate user, not an attacker trying to guess the OTP. Common reason for this behavior: session invalidation. We have rare limiting and log out policies. We have security-driven redirection and many other things. Let's cover the session validation. Upon failing the two-factor challenge, the application might invalidate the user's session as a security measure, forcing the user to start authentication process from scratch. Awesome, this is very good behavior. Rate limiting and log out policies to prevent attackers from repeatedly attempting to bypass two-factor authentication. The application may have rate limiting or log out policies in place that trigger after a set number of failed attempts, reverting the user to the initial login step and also locking out the user. Security-driven redirection. Some applications are designed to redirect users back to the login page after multiple failed two-factor authentication attempts as an additional security measure, ensuring that users' credentials are revalidated before allowing another two-factor attempt. Automation is the key. Automation makes life easier when attacking these kind of protections because of speed, consistency, recovering from logouts, and customization. Okay, speed. Manually logging back in every time you get logged out is slow and tedious. Automation can do it for you much faster. Consistency. Automation avoids mistake that might happen if you are doing the same repetitive actions over and over again. It's reliable. Recovering from logouts. If application log you out from a few failed attempts, the script can automatically log back in and keep trying. This saves you the hassle of doing it manually every time. This is true for an attacker, right? Recovering from logouts. If the application logs you out after a few failed attempts, the script can automatically log back in and keep trying. This saves you hassle of doing it manually every time. Yeah, this was okay. Customization. Manually creating an automation script for attack offers more flexibility than using a single tool like Zap or Burp Suite. You can customize your script to test specific scenarios, such as using different IP addresses or use agents or varying the timing between the requests. So you can create your own kind of tool in order to attack the auto logout feature. Okay, exploitation. The application hosted here automatically logs you out if the user if they fail the two-factor challenge. For demonstration purpose, the application also generated 4-digit PIN code every time the user logs into the application. Note, in real life application, the PIN code typically ranges from 4 tetra 0 to tetra 9. I think now people are using at least 6 digits, not 4 digits. We are only setting it to the lower value to save time, brute forcing it. Okay, so this is what they have. We have function which is generating the token, star value rand from 1250 and 1350, and the token will be available in this session. We return the success message using the Python script below. Save the script as expire.py and run it in your terminal. So this is what we can do. But before we actually run this in our terminal, let me open this one and do we have code installed here? Okay, we don't have code installed. Okay, it's okay. Let's go with the nano then in this case. Exploit.py. We'll copy paste the code, which should take care of everything for us. Oh wow, it's a long code, man. Okay, Control O, enter to save it, Control X to exit. Before we run this one, let's go through the code itself, right? We need to understand what we are doing. We are importing the request module. Then we are defining the URL for the login, two-factor process, and dashboard. This is the URL that we need to target, and this is the OTP multi-factor authentication URL, and this is the dashboard URL. These are the credentials we will use. We hard-coded these credentials. These are the headers that will bypass. So this is the user agent we're gonna use. This is the accept. We are accepting everything almost. Accepting language is EN, US. Encoding is gzip or deflate. Content type is a post. This is a post request, most probably because we are sending some data in the form of URL encoded. Origin is the same MFA website. Connection we are sending is as close. Referrer is this one. So the application or the firewall will say, okay, referrer is this one. That means this is a legitimate request that is coming up. Upgrade dash insecure request is equal to 1. I think this will enable us to use insecure version of the request. I think if you are using HTTP or something like that. I'm not sure about it, but this is what I can think of right now. Function to check if the response contains the login page. A user verification in the response or text, that means the status is 200. There is a function to check the session that posts we will post the some data on the login URL with the headers, and then we'll return the response. We are submitting the OTP code 1 2 3. Split the OTP into individual digits, as you can see here, and response send dot post OTP data we will be sending. We have headers, allow redirection is equal to false, disable auto redirection. So we'll go to the same page and debug OTP submission response status. We'll get the response status print out, and then we are returning the response. Okay, this is the function to check if the response contains the login page. This is the function to brute force the 4-digit OTP. Okay, this is the actual OTP. So for OTP in range 10,000, look through all possible 4-digit pins. Okay, so it is tetra 02, tetra 9. So that's why we have 10,000. Session request.session, create a new session. Login response, we will log in and then we get the login response. If it is successful, we'll say okay, login is successful. If it is failed, then we'll say login is failed. We'll try the OTP with 1337 first. We're trying this OTP and then the response, we're submitting the OTP here. If the login page response is unsuccessful, OTP attempt redirect to the login page OTP. Then this is what we're gonna display, that this is the OTP that we have used and it is unsuccessful. And if the response code is 302, that means it is permanent redirection or redirection temporary. Location underscore header is this one, session cookie session.cookie.get the dictionary. We are returning session.cookie.get dictionary if the location header is dashboard, that we are able to successfully bypass the two-factor authentication with the OTP that we are using. Otherwise, if it is failed, we are also printing it out, and if there is any unexpected redirection, we are also printed this out. At the end, we also in case there is other than the redirection, we are also putting the status code here, and at the end we are calling the brute force to do everything for us. So let's run this script. Click here to breakdown for script. I already explained you everything. You can click down here and see what they are explaining. Python 3 exploit.py. Okay, let's do that. Python 3 but why? Okay, but it always tried 1337. Okay, why is that? And they already given us the session cookie as well. I don't know. Okay, using the new PHP seed ID, SESSID, go to the third, open your browser developer tools and navigate to the storage and cookies. And then we're gonna create a PHP SESSID and put a information here, replace the SSID value with the SSID from your terminal. Once we do that, once again go to the same URL and we will be logged in. So this is the third one, right? Okay, so I'm pressing F12. I'm going to the application, no, storage. So this is the cookie that we are looking for. I'm gonna double click on the value, paste our own value. All right, then I'm gonna go to the dashboard URL. Basically, after you successfully authenticate, the PHP server will generate a cookie which will track your session. Okay, so this is the session which will make sure that okay, this is the actual user who already authenticated and he's allowed to access this dashboard. Okay, so here we go. This is our flag. I'm gonna copy paste here. This was interesting and this was easy, but also very interesting. We have completed in 47 minutes. Awesome, awesome, awesome. Conclusion. In this room, we have covered essentials of multi-factor authentication, MFA, or two-factor authentication, 2FA, giving you a solid understanding on how these security measures strengthen systems against unauthorized access. Key takeaways: understanding MFA. MFA adds layers of security by requiring multiple forms of verifications, significantly reducing the risk of unauthorized access. This is very true. Addressing vulnerabilities. Common issues like weak OTP algorithms and lack of rate limiting can undermine security, highlighting the need for strong implementation practices. Best practices. Secure OTP generation, rate limiting, and user education are crucial for maintaining effective MFA systems. I understand the need for proper MFA systems. Once you click on continue, congratulations guys, we have completed another room on tryhackme.com. So guys, if you haven't subscribed, please subscribe to the channel. Click on the bell icon to get the notification whenever there is a new video up on this channel. If you have any suggestion, please put it in the comment section down below. If you like this video, please consider subscribing and also give the thumbs up. And if you don't like this video, let me know how to improve it, and I will see you in another video. Bye bye.